Welcome to a new video in my home automation and Node-RED series, and today I'm reviewing this ESP32 Cam module which was supplied to me by iStation.com for this video. So I've received this module free of charge, and in this video I'm going to show you how you can program this device and how you can use the basic demo firmware or the basic demo sketch and then integrate it into Node-RED. And even with the basic sketch, I think this small device is very capable, because in Node-RED we can easily get a still image from this camera, and we can also get a live stream, which I think it's probably just, you know, these two are going to be quite good for so many different projects. And also the demo sketch has a lot of interesting other features as well. For example, this small device in its own can do face detection, and you can even train it to recognize various faces, and it would recognize that face against some other faces. So you can train it to recognize multiple persons, and it will do that, and it actually works. But what I'm going to focus on this video is just to show you some basic integration with Node-RED, how you can get the still image, the live stream, and also how you can change the basic parameters of the stream or the camera settings that you would normally be able to do manually on the website, which is actually provided by this unit when the sketch is running. The product comes as you see it now. So it's an ESP module on the background, and actually this is an ESP module which has an external antenna connector at the back as well. Of course, if you need to use the external connector or the external antenna, I think you need to desolder some of those really small pieces, which I wouldn't have any ideas how to do. And besides that, you have some, I'm guessing this is power management stuff. You have a reset button, and of course on the other side you have a micro SD card slot, and then a camera which comes in a fat flex, and it has a double-sided sticky tape, so I peel that back and stick it down, and also there is a protected like film on the lens, which I've removed since I received it. There is also an onboard LED, but based on the the firmware that I'm using is not using this LED at the moment. The only thing you would notice is this module doesn't have a USB port, so you would need a FTDI programmer to program the firmware on this one. As I mentioned previously, there are a lot of articles and then videos on the internet already how you set up the basic example sketch on this device, and I'm going to do the same. I'm going to use the same example sketch. So go to the video's description for the link that I've also used, and you can just go through that link. But basically all you need to do, as I mentioned, that you need an FTDI programmer. I have one that I've used on many other projects. I'm using the same that I've used to flash my Sonoffs and Blitzwolf devices. The only difference is that I got a model which has a 5 volt and also a 3.3 volt output. And for the ESP32 Cam, I used the 5 volt output. So in my example, I used 4 wires. So one was the 5 volt, the other one was ground, and you have the TX and RX. And you can see the screen, which is actually a screenshot from this guide, how you need to connect them together. And of course, you need another wire which connects the GPIO 0 to ground. You need that 5th wire to be connected as well. That's how you plug the FTDI into your computer, because then the ESP is going to boot up into a flash mode. So after that, you just find the example. And again, I had some difficulty because for some reason my program or my Arduino IDE didn't work the same way as I have seen in the example or in this web post. I had to pick a different board definition in the Arduino IDE, a different ESP32 board, and once I have done that, then the camera example appeared in my examples folder, and I just followed the same step. So I changed the SSID and the password in the sketch, and that was it. I selected the COM port and I just uploaded it, and that's it. Once the upload is completed, you can just remove the 5th wire, and then you can just press on the reset button so that it resets the ESP, and then it would boot into the new sketch. And after that, it was fine. So all you need to do is find what's the IP of the camera, and also remember that well, most cases that when you boot up, it would likely to get a different IP address. So furthering this flow, I've been using the IP address to access the image and the stream of the camera. So you would need to adjust this IP address every time you're using the camera, or what is probably the best way is to go into your router configuration and assign a fixed IP address for the MAC address of this ESP module. Or actually, you can even modify the the sketch. There are plenty of examples how you make an ESP Arduino sketch to use a fixed IP address. Probably that could be an easy solution as well. And once the sketch is up and running, you just open a browser and you point to the IP of the ESP, and you get this familiar user interface that you have seen on other tutorials as well. So I was just playing around with it, changing the resolution, and there is a lot of other things that you can change. But even on the default settings, white balance auto, gain set to auto, that's probably the best in is for more general use. If you have some really challenging scenario, I don't know, backlight or something that you might want to manually control the gain, but I think for most cases we are just going to leave it on auto. And I've also played around with the face detection functionality and the face recognition. So again, you can turn both of them on. You can enroll faces so it remembers the face, and then when it recognizes faces, it will be able to tell which user is which. I haven't managed to get this information out of the ESP, as in to, let's say, send it off to a server or get it, make that information available, but that's probably going to come in the future. By the way, I found an interesting post somewhere that if you want to particularly use this functionality, somebody has created a modified sketch where it will pull a GPIO output of the ESP if it recognizes a trained face. So you can use that to, for example, pull a relay. So you can, for example, put it on a door, and when it recognizes a trained face, then it will open the door. Otherwise, it will not do anything. So that's one specific sketch you can use if you want to build such a solution. Okay, so this is the following day, and I had some time to play around with this board and also to play around with the NodeFlow. So let's look at how it works. I briefly talked about this user interface now, so I'm not going to talk more about this. And actually, well, most of the things that I found out how this unit works is actually based on looking at this UI, and then trying to figure out what sort of messages are going back and forth between the main screen, sorry, this UI and the server running on the ESP. And I managed to find these few things out. So first of all, actually let me close this and I open up a new tab. So the first thing is, if you call the URL, which is the IP and /capture, then you get a snapshot, a JPEG image of the camera. So if I just move the camera to point myself and I do again, ooh, yeah, it's working. So it's very easy. Again, it's, if you have watched one of my previous videos on the Reolink cameras, which provide a URL that you can get the current still image, it works exactly the same way. You just point it to a URL. There's no user ID, password. It's simple HTTP, so you can just call it and then save the output. And that's what I'm going to do in Node-RED. So that's the first thing. The other one is a stream. So if you happen to port scan this device, it actually opens two ports. One is 80 that we have seen already, and there is another port which is 81, and that's where the stream is. So you get the video feed, and the best thing about this video feed, this is not a RSTP feed, but it's an motion JPEG feed. So the browser can just display it as it is. So again, it should be very easy to integrate it into any website, home automation dashboard. So it's more easier to work with than with RSTP. So that's the stream. The next thing is you have a URL which is called status. And in this one, the device returns a JSON, which is basically going to set the different formats, the different settings. And the good thing about this one is if you also bring up the main screen. So let's say at the moment, if I refresh this one, you see that, never translate. So you can see that the frame size is 4, and that's basically the resolution. If I change it to, let's say, 800 by 600, and I refresh this one, it becomes 7. So you can really easily test all these parameters, because all you need to do is you bring up this side, you change the values, you refresh the status, and you will notice what has changed and what value it is changed with. So you can easily correlate the values here related to the values that you see on the screen. So I think that's quite nice. And the last thing is, if you want to change any of these values, I mean, this is how the main page is working as well, then you can call again the IP/control $var as variable equals, and then you call the attribute that you want to change, and then and val equals, and then the value. So if you want to change, for example, the resolution to 800 by 600, then you do control $var equals frame size and val equals 7, because we have just seen how it gets returned in the status, so that's how it needs to be called in the control function as well, or this control URL. And honestly, that's pretty much what I used in my NodeFlow as well. And I wouldn't say I've done all the functionality. I just wanted to have a very simple integration between Node-RED and this ESP32 camera as well. So we have a couple of functions. So we can capture the image, and the image got captured. We can start the stream, and as you can see, the main stream got started. We can stop the stream. Again, we can capture an image. We can set different resolutions. So if I set the VGA, I get a message that the VGA got set. So if I capture again, then we get a smaller message. And of course, it works with the stream. So now I start the stream, it starts in the low resolution. By the way, I can even change the resolution in between while we are in the stream. Oh, by the way, yeah, so VGA is that's 800 by 600. I think QVGA is, what is it, 640 by 480 or something. And yeah, and I would say for a lot of integration, this is what you want. You either want to show a live stream or capture a live stream, or you just want a still image. And with this flow, you can do it. And I've also added some small gimmicks. So for example, let me get my phone. So I was just getting my phone, and if I click on this one, last send image in Telegram, whoop, yeah, I get a message that that's the last image from the ESP camera. Of course, it gets sent in the resolution that it was taken last, so it was the low resolution, so it doesn't look very nice. But if I take another image of my laptop, and if I send this one, then I get another video of my laptop. So it works. I think it's nice, good. And if we want another image, okay, it's too bright, and we want to send it an email, then if we just wait for a few seconds, then the email arrives. I just wanted to show it on my phone. So simple Telegram and email integration. I said it's easy to integrate this unit with Node-RED, and actually based on the what you have seen on the dashboard, the flow which makes all that functionality happen is basically just that much. So it is really simple. So let's take the camera capture, or the still image capture functionality, the first. So I'm using a UI button. There's nothing special about that. So it's just a button which sends out a message. And then I'm calling the URL for the capture. So it's basically the http://ipn/capture. You don't have to set anything. The return is going to be a binary buffer, so that's the JPEG image. So all I'm doing in the next step is I'm putting it into a file out, and I'm specifying the image path and the image file name and extension that it needs to be saved at. So it is always going to override that single file that I've created, and I've saved it in the Node static folder, which I have configured in my settings.js. And what I'm doing next is basically, well, as you can see at the end, I have a UI template, which is, just the default one. So whatever I pass in the message.payload as an HTML file, that gets inserted into the HTML source of the the dashboard. So all I'm doing is I'm creating a simple paragraph, and within that I'm creating an image tag. And the reason I have all this extra code in here, because I'm always using the same image file name. So I'm always overriding the older image with the newer ones that I've taken. And if I tell the browser to display this image, and because it's the same image file name, the browser would think that it hasn't changed, so it's not going to read it from the server again. But if you add this time equals something, which is the year, month, date, hour, minute, and second, so that will always be different. That just forces the browser to always read the same image, the same JPEG file, which is, well, definitely it's going to change because I take a new picture. So that's just a trick that I learned from a comment from my previous video. So that's how you take an image, and that's how you display the image on your dashboard. So very simple. The streaming, starting and stopping the streaming, is equally simple, because as I said previously, the ESP Cam creates a stream which is an MJPEG stream, so that can be displayed directly by the browser. So all you need to do is again create an image tag, and within the image tag you supply the port 81/stream URL, and that would get displayed as a moving image in the browser or by the browser. I'm guessing maybe it wouldn't work with a really older version of Internet Explorer, but yeah, I'm using Chrome. It works fine. To be honest, I haven't tested with other browsers, but I'm guessing it would work the same way as in Firefox or Safari or probably the latest version of Internet Explorer and Edge. So that's simple. And if I want to stop the stream, I generate a new URL which doesn't have an image, and well, it doesn't get displayed anymore. The next couple of buttons on the screen were setting the different resolution. So it is just two examples. I wanted to show you how you can set the resolution to 800 by 600 or 640 by 480. Yeah. And as I mentioned previously, all you need to do is call another URL, which is the /control. And for example, here I'm changing the frame size. So I'm changing between value 6, which is I think that's the 800 by 600, and the value 3 is the 640 by 480, or I think it's the other way around. Actually, I got the text incorrect in here. But what I'm also doing, and this is something that I've also discovered when I was debugging, is that the face recognition only works in low resolution. So even in the standard or the stock UI, when you are changing the resolution, the device automatically turns off the face detection and the face recognition, because it wouldn't work in high resolution and probably would give error messages or something. So I want to do really good housekeeping, and I'm actually doing the same. So I'm always turning off the face detection and always turning off the face recognition as well before I change the resolution. And of course, if you would turn on this face detection manually, then whenever you set the resolution from here, it will turn them off. And the last two examples are the Telegram example. So here I created two buttons as well. Again, nothing special about these buttons. They don't send out any special payload, so they just send out a payload, which I'm turning to a Telegram payload. So I've hard-coded my chat ID here. I said that the type is photo, the content is the URL, sorry, not the URL, but the path for the JPEG that I have saved. So again, because it's the same file name, it's just easy. I can just hard-code the location here, and then you have a caption which says, this is the image taken by the ESP32, and that gets sent by Telegram. So you just point it to your Telegram account. This is a Telegram sender. Yeah, that's just a Telegram sender node, which I have it configured for my bot. And the other one is sending the email. Again, nothing special about the button. And in the email content, you can set up an email with an attachment image like this one. So again, the file name is the camera image JPEG. So that's the file name that you will see in your email application. And then the path is again the path for the file that you want to attach. And you just send it off to an email node. So I'm going to include the link to this flow in the video description. Of course, it's going to miss these two nodes here because that's my account, so I don't want to include them in my flow. So I'm just going to substitute them with a debug node. So just put a Telegram sender and just a simple email node, and then configure it, and it's going to work for you. And of course, with these two examples, I've taken a little bit of shortcut because I just assume that, you know, when you are pressing on these buttons, you have pressed the capture image. So there is an actual image which has been taken previously. But if you want to create a flow where, you know, it takes an image and sends it to a Telegram, then all you need to do is you call these two, and then from these you go to either the image message or the setup email content function, and then to the Telegram and then the email flow. But that should be all. I think I will play around with this module a little bit more in the future. I want to do more image processing and image related projects. And I think the first thing I'm probably going to use this small module for is to monitor my 3D printer. So when it's printing, then maybe it just should send me some images every now and then, so I get updated on the progress of the 3D print. I think that would be nice. But hopefully there's going to be a few more projects in the future. So stay tuned for those. They are definitely coming. But that would be all for now. Thanks for watching, and hopefully see you in the next video.